Okay, part 3. Oh, and let me turn my timer on. 6:40. Okay. All right, so continuing with this struct for website shit, but we need to actually get the information from the user. How should I do that? Should I do one extraction thing and then it yields a temporary? I mean, I guess that could be one way. I could have a different function for each. That's also a lot of functions. Could just say, so this takes a reference to it, and then we could have one that just yields one, right? So we could say a website stats function called get website info. Doesn't take any parameters, and it has 3 parts. Enter ads watched. And then we could have okay, and then we can okay, and then enter, and then enter double, yeah. You could say clicked, sure. And then finally, return website stats, ads watched, users clicked ads, earnings per ad. Cool. Then we could say t get value. Do I do one for int and for? I mean, I could just do an overload. I guess I'll do an overload, because then I have to handle any other implicit conversions, maybe. Oh no, because we do the template and it only generates for the code that we have, so maybe this is just a better way than writing overloads. So we'll say t get value, and it takes, oh, but fuck, we don't want a template because we want get in and get double. We don't want Well, I kind of want to do the same for either. I mean, it's slightly different logic on the inside. I mean, I could just do standard character input for it. I mean, I could do a string view and pass it. The problem is there's no way for it to know which one to use. Do we just do an overload? I guess so. Alright, I'll do that. And I shouldn't even do an overload because this is getting a double versus an int. Yeah. Or maybe... What if I had... It doesn't care because this is a temporary variable. So we could maybe do that, huh? Maybe that works. Let's try that. Template, type name T. Okay. Void, or T, get value, T. Okay, we don't do anything with it, but we have a T and a standard include string view. Oh, string view. Prompt. Let me say while true. Prompt. Okay. And then we make a, oh fuck, but can I make it a T? I don't think I can. Maybe I can though. Maybe I can. I should be, right? Value. Oh. Still good. Okay. We also need numeric limits, but... Okay, we can ignore line by doing standard character input dot ignore standard numeric limits, standard stream size, max. Okay. And program if UF character entered. Clear and valid input. If it's invalid, we do this and then get input. Alright, try getting input again. Continue. And then we can say if standard character input dot peak is not equal to the inline character, then character input dot ignore, and we could do standard numeric limits, standard stream size. Sure, I could make a an ignore line function, but it's fine. Check for and remove extraneous characters. Okay, so if it's not that, it's not that. Then finally return value. Oh shit. Alright, now here's the question. So we call this with double and then the prompt. This should handle it. And this should yield a double, this should yield an int, this should yield whatever. But in this case, I'm going to do enter ads watched. And actually, get web info. And I could just say get web info and we'll pass it int and enter ads watched. Wait, well, hold. Oh, don't tell me you need a fucking value. Oh, that's so annoying. Are you kidding? We'll just say 0. What about... That works. That's more explicit. And then we could do get web info double temporary. And then we could say again, get web info double. Or we could say, I mean, this is more straightforward than just doing 3 separate calls. Return values, create a website stats. This time, we're not printing website stats. We're printing get website info. Enter as watched. Oh, this shouldn't be an inline character. Oh, oops. Yeah, it shouldn't be. Should just be printing the prompt. 100 ads watched. Let's say % of the time, or 5%. So it's really that divided by 100. Divided by 100. $100 100 users, $100. 1% of people, so it's 100 ads were watched. I mean, honestly, it doesn't really matter. The percent really shouldn't be in there. It should just be watched in that, but whatever. In this case, it's just 100 times 110,000. Cool. And this is a constref, right? Yeah. Okay, so we have the struct, website stats. Cool. We're outputting stuff here, we're outputting stuff here. We aren't outputting stuff here, so this can be a const expression function. No, it cannot. Because there's a struct in it and it's a user-defined type, maybe. All right, program-defined type. User-defined includes the standard library. Excuse me. Print web stats. Ads watched, percent of users, earnings per ad. It's honestly not too bad. This is fine. We pass a reference to it to print it. And then we output the total earnings. And then we use a template to get any kind of value we want. We just have to pass it a temporary that we don't use, and it's just it's only as expensive as a regular little value because it's an R value. Excuse me. That way it's one function to get doubles, to get ints, to get floats, to get characters, to get bools, to get whatever the fuck we want. And in this case, it yields a double. In this case, it yields an int. In this case, it yields a double. And we pass it the prompt we want it to enter. And it has a string view to it, so it's cheap. Cool. So when you enter the values, store them in a struct, we pass them to be printed, and it prints that. Cool. And sure, we could have one function that does it like that. But this one gets the info and returns it. But it doesn't handle the errors. And I would want to loop if any of these values were wrong. So we could say, like, let's say if value is less than 0, continue. So -5, 5,000, -3, 52%, 100, 0.52%. Oh, and I should put percent there. This percent oh, well, I guess it's getting the chance, so it whatever, it's fine. In this case, you had the same shit there, got it in a function, and then printed it, and you could do 3 separate ones like this. Following line is split it to reduce the length. Boom, boom. Yeah, you could do it like that. It's the same shit as what I did. Create a struct to hold a fraction. It's too hot. As a numerator and denominator, a function to read in a fraction from the user. and use it to read in two fraction objects. Wait, what? Oh, okay, so we get two different ones, and another fraction should multiply them and return the result. And then another function that prints the fraction. Okay. So struct to hold a fraction. Let's start with that. And let's go ahead and just push this little website info example. Let's do struct fraction int numerator int denominator okay. Read in a fraction from a user. So we could have returning a fraction, get fraction, enter numerator, oh, doesn't know what that is yet. Enter numerator. Okay. And then we could just have int numerator. And then, sure, if I don't want to handle anything crazy, and then enter denominator. Denominator. Return fraction numerator denominator. Cool. And we could make it const. No, we can't because it's getting changed. Duh. And then I could have a function that prints it. Or let's see. So this we can now get it. Oh, we have a function to multiply fractions, so we can have and what do we return it? And return the result as a fraction. Okay. Fraction multiply fractions. Fraction 1, fraction 2. And then we can return fraction. And then we can say fraction 1 dot numerator times fraction 2 dot numerator, and then fraction 1 dot denominator times fraction 2 dot denominator. Cool. And then to print it, sure, we could say void print fraction. Let's say it should be const. And I guess these could be references too to be made cheaper. And then this could be a const fraction reference fraction. And we could say fraction. Numerator, fraction dot numerator, denominator, fraction dot denominator, oops, fraction form, fraction dot numerator, oops, right? Yeah. Cool. Print separate values. Print fraction form. Temporary fraction as product of fractions. Return temporary fractions product of fractions. Get to fractions. Or well, get numerator and denom. Okay, and then we could say fraction my, or we could just say print fraction get fraction. Okay, 3 and 4. Uh-oh. Oh, well, I guess I should probably do print fraction multiply fractions get fraction. Hold. Oh. Multiply fractions. What was it called? Multiply fractions. Yeah. Okay. 3 and 4. 3 and 4. So we get 9/16. So we get numerators 9/16, 9/16. And then we could say and we could try and make a fraction that reduces them, and that would be what? Checking to see if if the bottom is or if the, what do we say? 2/8. We check if 8 is divisible by 2. Let's say it's 3. 3/8 no, but 2/8 yes. And if it is, divide 8 by 2. So what do we even say? What's the formula for that? So let's say like 3/9. And we say, like, let's say we have 10. That's hard. 10's tough. How about 2/4? Or like 7/58. And then we have 14/116. So what do we say? We say it's divisible by that. Oh, so we say the bottom divided by the top to get some value. Hey, like, what am I? So we have like 17/54, and then instead we have, or let's say, right, 54 works. But then we have 34/108. So we say divide the top and the bottom by 2, or so we divide it. Wait, hold on. I mean, I guess you could check to make sure each one's not prime, and then you divide it by the largest common. Yeah, I guess so, huh? And then you could do some recursion shit. Okay, whatever. I don't really care about math stuff. It's boring. Cool. Okay, anything else? Can we make anything constant expression that I probably should have? Yes, I should have done this. Const expression. No, I can't because it's a user-defined type. Never mind. It doesn't matter. It was that I guess there was some hidden input and output somewhere. What happens if I make this a const expression struct? Uh-oh. Not good. Can't be. Oh, it works. What is it complaining about? Oh, it just ignores it, I guess? Compiles it out, maybe? Everything's const. Cool. Multiply. Well, fucking yeah. Alright, hold on. Okay. Should match the following. Enter value. Boom, boom. Multiply together. 10 over 2 and 2 over 10. So we get 20 over 20. Mine was more compact. I'll take it. Never mind, no, it wasn't. Because these are all separate. I printed extra stuff. It's not bad. It's only a couple lines more, and I printed a shit ton more stuff. In the solution, why does fraction return by value instead? Wait, what? Hold on. Why does get fraction?
Because you are returning a reference to a fraction. Hello?
You're returning a fucking temporary fraction. Hello? Oh, you're saying, why do we make it return by value instead of return by reference? I thought you were saying what it's doing. Obviously, it's returning by value. Why are we doing it instead of returning by reference? If we return a reference to a temporary variable, motherfucker, we're going to get some goddamn dangling. What? Struct miscellany? With pointers and references? Oh yeah, I was doing that. A pointer to the thing dot something, because we actually have to get the object and then take the dot, the member selection operator. Struct miscellany. It's too cold. Structs and classes can have members that are other program types. Oh yeah, we did that earlier. I could have a struct that takes us something. Oh yeah. A struct with a struct in it. We define one program defined type, then use it in another. Well, it doesn't have to be in the global scope, but it could be in the same scope, so that what's aware. Doesn't even have to be, actually. They just need to know each other. Excuse me, we have a company, and it has an int number of employees, and then the employee CEO, which is an actual employee. Oh, nested initialization. Let's test that out. So we have we could say struct gunpowder, and it has an int volatility rating, and then we have a struct bullet, and it takes, and it has a and it has a oh wait, hold on, wait, what? Wait, yeah, oh, and it has a gunpowder. Oh, why the fuck is gun p used to this damn camel case, yo? Grain count, maybe? And it has a gunpowder. And it has a gunpowder. Can't give it a temporary, huh? Cool. But it has a gunpowder called bullet powder. and then it also has double mass. We can create a bullet, big bullet, and it is initialized with gunpowder, so it has a volatility of, let's say, 7 and 4, and then it has a mass of 3. What we could do, we could say dot bullet powder, and then we could say dot mass. Or we could say dot bullet powder has a dot volatility of 5 and a dot grain count of 1,000. Uh-oh, hold. No apostrophe. So bullet powder has a volatility and a grain count, and then a mass is just a mass. Bop. Cool. Oh, meaning like the company is literally created with employee defined inside of it. So you can only access employee in company, I think? Maybe? Yeah. I guess you can only get strength inside a character. Strength doesn't exist outside. You can't put strength on anything except a character. Define an employee struct, then used it as a member inside company, and it was defined separately outside of company though. Then when we initialize company, we initialize employee by using a nested initialization list. Yeah, because you're initializing the employee that's inside of company. So you're initializing employee via initialization list, but then you're also initializing the aggregate of company. We want to know what the CEO salary was. Member's salary. Oh yeah, because we could say whatever the company is, dot CEO dot salary or dot wage. Just like standard chrono, steady clock, time since last epoch count. Standard chrono, steady clock, time since last epoch count. 5 nestings. If it only exists there. Makes sense? For example, we could have struct character and it has an int health. But then it has a struct strength. Oops. And strength is an int strength level. But then it also has a health bonus. Something like this. Or it's like strength has power bonus and health bonus. And so maybe strength is it's a 2 variable thing. It's not just one. And so if we had int main, and then we had character zombie, we could say, okay, hey, a zombie has health, dot health is 100. But then, oh yeah, we could say dot, oops, hold. Oh, well, I guess we should also, how do we do that? Do we give it a strength and then give it what if we said can't name it? We could make a strength character strength, like that, and then we could say character zombie, and it has a dot health of 100 and dot character strength of dot power bonus, we could say, to make this real funky, is 3 and dot health bonus of 4. And it looks kind of weird. Or we could just say 100 5 3 pop. That is infinitely shorter. Let me say, hey, this is the zombie. There you go. It has an integer of 100, and then it has 2 more integers inside of it as strength. And here's strength, but then here's the whole thing. Here's just the inside of it, but then here's the struct and the nested struct. Here's just character strength, but then here's character. Oh yeah, I guess that's what you would do. You'd probably define the, the struct up top, and then you'd create it later with the actual members. And so another way we could do it is those were out of order. Hold. Gotcha. So we can't say that. We could. Oh, that's how we can create a type of something, though. Like, could I make a character strength health bonus? This? Yeah, we wouldn't use this. These are properties of objects. These aren't just definitions of types. This isn't like a namespace. We have to create a character, and then I can access its specific shit. Seems like it's useless. The scope resolution operator is not useful there. Nested types. Owners and viewers, okay. Structs that are owners should have members that are owners, so that if you view a struct that owns something, then the shit inside it needs to own it and shouldn't be a view to something else, maybe? So within an owner, you shouldn't have viewers. That way, if you view the owner, you're not viewing a view. So maybe no string views inside structs. What about pointers and stuff too, huh? Oh, yeah. So an actual real type, not a viewer. Owners and viewers. Owners manage their own data. So I mean, a pointer technically does, but it's really looking at the address of something else. So if we dereference it, we're getting that thing's value. It doesn't really have its own real useful value. And they don't control, yeah, exactly. Pointers and references do not control when the value they hold are destroyed. Viewers use someone else's data and do not control it when it's altered or destroyed. Makes sense. True, yeah, because then the values could be dangling at some point. So like if I create an object with a view to something, if that view to something is invalid, then a piece of the struct is invalid. True. Yeah, that would we get some unchangeable. Good. Makes sense. Yep. Yeah, because we have, let's say we have a character, and in the character is a string view to the target. Then, I mean, is it an issue? I don't know. Just looking at some other shit. I mean, I can always check if it's valid. I think that's an appropriate case. Yep, makes sense. I don't think it's bad for a character because then we have in the character a pointer, ideally, not a reference, a pointer. Well, yeah, I don't want a reference. I never want a reference. But a pointer to something, then this could be cool because then we can just check, hey, is it null? Okay, it doesn't have a target right now. It's fine. Or like a standard optional for like, I don't know, clothing or something, whether you're wearing it or not. Probably just better to have an object, honestly, but or an object for it instead of that. But best practice: structs and classes should be owners. Owning type: no views, pointers, or references. Okay. Practice safe structs. Don't let your member dangle. My member's always dangling. That's funny. Okay, German rap is kind of good. Oh wow, okay. I wasn't reading it properly. Practice safe structs. Don't let your member dangle. Nice. Makes sense. Never string view. Yeah, gotcha. If we get a viewer and then we put that viewer inside the owner, hold. And then we create an owner, and then we create a viewer, but we create an owner of get name. But then get name returns a standard string. Okay. But then we return a viewer. We're returning a view to something. Excuse me. So just don't have structs that have views at all, because then we can't even use it unless you evaluate it first every time. Because then we're getting a view to it. We're viewing a C-style string. So actually, we're viewing a standard string somewhere after it's destroyed, which is undefined. Yep. Yep. Expensive, but okay. Well, as cheap as it'll get. Makes sense. A data structure, holy. Meaning there's some extra overhead. Extra 2 bytes there. Let's try. Oh, yeah, sure. Oh, I guess it can't be a const expression because the object hasn't been created yet. It's like having a const expression int before you even make an int. Cool. So I can get the sizes of these. All right, cool. Whoa. $12 and 1, 13. Then we get 16. What if we remove max health? Oh, seems like there's always a 3 overhead. What if we remove, is it 4 if there's just a bull? Oh, I guess not. So there's some overhead when combining things, seems like maybe an extra byte per extra thing going on. An extra byte per data member. Oh, it's an extra byte maybe per data member past 1. Which would explain why mine was 13 and then 16. Because I had, if it was 1 and 1, but then we added 4, it gained 4, 4, 4 plus 1, 1, 1. That's 1 plus 15, that's 16. When the itemized sizes are actually only 13, 4, 4, 4, 1 plus 1, 1, 1 would explain it. And it would explain it here because he has three variables where it should be like what? Oh, okay. 8, 4, 2 and then plus 1, 1 for 2 more than 1 member. Okay. So far that explains how it is. At least, gotcha. Padding. Oh, gotcha. Maybe so that it's easier to get to that piece of memory. I don't know if it's the same as electrons for charging, but the analogy still stands. A more empty parking lot is easier to park in. Seems like he's saying that here, actually. He's adding, after member A, he's adding an extra byte and a byte. Wait, what? Wait. So more padding is had after a short because, oh, why? Because it's not an ideal size, so they pad up until the size. So if we just assume that a short would be more efficient as an integer if it just blocks off that whole piece of memory. Instead of having 2 little cars parked in the same spot, we say, okay, what's the minimum size of a car for this parking lot? Well, we like 4. That's an integer. We like integers. So instead of being able to pack 2 and 2, no, sir, you get 2 and then 2 of padding, and then you get 2 for your car and then 2 of padding. That way, in this case, we actually get 4, 4, 4 for 12. But for food 2, I would think it would be the same, but I guess not. In that case, it doesn't add the padding. So the order is mattering in this case? Yeah, I mean, that's surprising. And is it because it thinks, oh, short is going to be the default size for this? So anytime we see a short, we have to pack. But if we say int here, then maybe, Minimize padding by defining your members in decreasing order of size. So the biggest guy first. Okay. Oh, good. Member selection with pointers and references. References could be interesting. A reference to an object's member? Or plus equals 3000. References to an object act like it. So we could use that to select the member from a reference to a struct. So we could have a reference to a struct, and using the member on the reference is getting the member of that struct. Okay. Yeah, so we can, well, that's actually what we've already been doing. We pass by reference, and then that is not the object, it's a reference to it. So it's operating on the object, but through this intermediate party, the reference, e.id. Even though it's Joe that has an ID. Regardless of the same type anyway, so. But it's getting the actual, it's looking into this guy. The one that it received by reference. Man, this is fucking killer. Well, yeah, it can't be used directly on a pointer, cause a pointer ain't got no members to it. Tell you what, it's got a damn address. You can't get a damn member of an address. Address is a damn address. It's a damn integer. Ain't no damn member of an integer. But you can dereference that hoe and get yourself one of them good old boys. Por ejemplo, we have it may struct motherfucker, and a motherfucker include a string. Need standard string. Const standard string name, and his name by default is Steve. And he has a mass, double mass, and he weighs 90 kilograms, and he's got an integer height, and he weighs 72 inches, he is 72 inches tall, 6 feet tall. Bop. That's the man who's fucking the mothers right there. So, what have we got? We've got, I mean, these are default values, so honestly, we don't actually need this. Could just leave these default, or rather value initialized, and then we can create a motherfucker named Steve with a name Steve, C-style string being converted to a standard string, a mass of 90 kilograms, and 72 inches of height. And we could say, well, we don't need to do all this, it's fine. We could say a motherfucker reference called Steve reference is Steve. But then I can't have no damn pointer to a reference, so I can't have a motherfucker reference pointer to Steve R pointer to Steve to address of Steve R. No siree, ain't allowed. You can't have a damn pointer to a reference. However, we can have a motherfucking pointer to a damn Steve P to the damn address of Steve. Tell you. And now what we can do is we can do Steve R dot whatever. He got a damn name. He got a damn mass. And he got a damn height. But we also got a damn well, we can do two different ways. The dereference operator operates first. So this is dereferencing Steve. Or we could say, rather, we're not doing that. We're dereferencing Steve P dot. So we got Steve P. This turns him into the damn object we're looking at, Steve. And he's got a height. Oh, shit. I don't know about that. How about we say dereferencing Steve P dot height. Line 20 has an issue. Hold pointer to use the reference. Okay, hold. We're okay for now. Wait, I had some stuff. I had something happening earlier. What? Operand of that must be type pointer but has type double? What are you talking about, yo? Hold on. Why am I fucking this up? I passed him by address earlier. He got the address of Steve. Bro, I swear that's what was happening. See, so far we're still fine. Whoa. Whoa. Wait, how is all this fine? Was I doing Steve R the whole time? What? Wait, what was the fucking problem here? Wait, why was it cool a second ago? All of that is totally fine. Why is this now cool? So it's cool here, and now it's cool here. What changed? Steve P's height is cool, and I can remove this. And I can remove, and now this is now this, and I can update it through the pointer. But earlier, not cool. Why? I do not understand. Okay, so now he's being used. Oh. Wait, so that was never the issue? Bro, what? Oh. Wait, you don't dereference him to get it. You can point to it like that? Whoa, I thought I totally... Oh, true. Because in that function, I was doing it differently. I made a function. mf'er.height. I wasn't doing dot dereference mf'er to get dot height, but I can also do that too. So if I dereference, oh, the problem is it's a pointer to the value. What, didn't I? I thought I did it like this though. Steve P dot height. So that's fine, but Steve P dot height is not fine, and the reason is because it's a pointer to this value. I thought that it was working on this. I forgot that it is. It's thinking it's a pointer to this guy. This is looking and it's thinking it's a pointer to a motherfucker's height, a motherfucker's int. And what is the error here? The operand of that is an int, so we're dereferencing an integer. Because it turns out you can actually do it either way, seems like. Include IOStream. Sure, why? Because we need standard character output. And so we can do this two ways. Dereference Steve P dot height. What is happening here? Hold. I'm not sure why it's having a problem with this. Why is it now having an issue with height? What changed? I'm dereferencing Steve P and getting his height. Unexpected end of file found. Oh, there's a fucking B there! The B! The B was fucking me over the whole time! I should have looked. I wasn't looking at the freaking error, dude. I wasn't looking at all of them. I was looking, it was saying some weird stuff here. And I don't really know why, but somehow the B is fucking everything up. Oh, well now it's just expecting an extra parenthesis. But we could just do that, I think. And now it's cool. What if we did pointer or dereference Steve P dot height, no go. You gotta do dereference Steve P to get the height of the dereferenced object. But then we could say standard character output, Steve P dot height, like that. And we can get the same value, just two different ways. So I guess the pointer guy is the same way of dereferencing it first and then getting to it. Because Steve P dot height won't work. There's no, that's the, Steve P is an address. But we can dereference it and select it. How long is this gonna fucking? So 6:40, and then 7:10 of break, and then 8:40, and then 2 hours 20 minutes. That's not bad. I got basically 3 hours of screw around time so far left today. But I have to eat too. Oh, I'm still freaking tight from kickball, damn, from running. Won't compile because we're doing dot or pointer dot instead of saying dereferencing the pointer and then doing dot or pointer pop pop dot. And here it comes. It's gonna have another section for the chaining operator. Oh, there it is. I just autopilot read that. I figured it was gonna show an operator, but I didn't know what it was actually called. Figured it was gonna title it like that. There we go. Compile error, can't use operator dot with pointers. We can access objects directly. Because pointers hold addresses, we need to dereference it first to get the object before we can do anything with it. And the dot operator is above the member selection operator. It has higher precedence than the dereferencing operator. And I guess the point is it'd be cooler to, well, I don't think it's not great. I don't think it's bad at all. We have a struct. We have Joe. We create an instance of the struct. We create an object, Joe. We can increment Joe's age. We can change Joe's wage. I can get a pointer to Joe so that somebody else can look at him. A function can look at him or something else can look at him. We can pass him cheaply without reference. And it's a pointer because we need to reseat it maybe instead of a reference that we can't reseat. And what we can do is we can take Joe, or we can take the pointer to Joe, put in parentheses, and dereference it. And then, to make sure that that operator happens first, that operation, we dereference the pointer to Joe. And then we get the ID of Joe from that. It's a bit ugly because we need to parenthesize it, so it will take precedence over the member selection operator. Yep, exactly. Offers a member selection from pointer operator called the arrow operator that can be used to select members from a pointer to an object. Oh, so the chain operator would be a pointer to a pointer, maybe? Offers a member selection from pointer operator. Bomb, bomb. They can be used to select members from a pointer to an object. So we create a pointer to Joe, and then we just go straight to ID. So we're selecting a data member of the object we're pointing at. That's pretty cool. It's like dereferencing and getting the member in one step. Boom, boom. The member selection from pointer operator works identically to the member selection operator, but does an implicit dereference of the pointer. Oh, so it dereferences it before? Okay, that makes sense. Yeah. Cool. It's easier to type and less prone to error Because the indirection is implicitly the indirection? What are you talking about indirection, bro? Oh, the indirect. What about the indirection? Hold on. Indirection. An implicit dereference, I guess we call that. So we say it does the indirection for me instead of me having to. No precedence. Gotcha. Oh, the indirection meaning that it basically has it in parentheses. Okay. So I guess you do the operator like that. It's a binary operator where you have an object in the object's member, data member, and it returns what, a reference to it? I'm not really sure how it would do it. I mean, maybe it's just literally like a compiler shortcut. Or maybe it's an operator overload. When doing member access through pointer, use that instead of the dot operator in parentheses and the dereference. So yes, instead of it's literally parentheses, dereference dot something instead of just arrow something. The chaining operator, if the member accessed via operator is a pointer to a class type, meaning a pointer to a struct, we can chain it again. Hold on. Meaning if I have a pointer to him, what are you talking about, bro? Oh, meaning, do you mean like if I have chained definitions, like I have a struct defined in a struct or an enum in a struct, where I can then, or well, I guess not an enum, but a struct, where we have a pointer to a struct, okay, and we want to get one of its members, but we want to point to one of the members. So we do pointer to CEO, pointer to employee, or hold on. So we have CEO, so we have CEO pointing to employee, CEO pointing to employee, pointing to age. Courtesy of reader Luna. Okay, struct point, X and Y, struct triangle. A triangle has, oh, if the member is a pointer to a class type. So we have a triangle. My brain is not working right now. Hold. So we have point, which is X and Y. We have triangle, and it has 3 pointers to points instead of just having 3 points. I don't know why you would want that, but let's say you did. Excuse me. For example, we might have character, and in character, we have a pointer to a target. And what we want is information about target. So what we do is we say the character, point to target, point to the info. So in this case, we're probably going to say triangle, point to A or B or C, point to X. Pointer to C to X. Instead of this, he said Y. Instead of A to X, we said C and Y because he's a weirdo, but it's fine. And we have point A, B, and C. And a point is a thing. And then a triangle includes pointers to them. Oh, that's how you would do it cheaply. So you wouldn't make triangle an expensive so you wouldn't have points being separate things and then triangle being an expensive thing that holds them. You could just have triangle be cheap and hold pointers to them. But note, this is a struct that is not an owner. It is viewing A, B, and C. Because if A, B, and C will hold, if A, B, and C, get destroyed, or rather, if the things that A, B, and C are pointing to get destroyed, then A, B, and C will be dangling, bucko. So just be aware. So we have A, B, and C, and then we create a triangle, and we get the addresses of those points. And then we have a pointer to a triangle. if we have a pointer to a triangle, we can do the pointer to one of its members to A, to one of its members be X. Because we have a pointer to a class with a pointer to a class. So if it's a pointer to a class, we can go straight to a member instead of having to dereference it. Instead of having to dereference it and then get the member, we could just go straight to the member. A pointer is a pointer to a triangle, which contains these members that are pointers to a point. So if we want to access member Y of point C, we say, okay, pointer to C to Y, because C holds Y. All right, let me make this totally work in the brain. Let's do a little example. All right, well, I guess we could just say struct character struct target int health, and it has a pointer to target, character target, so we could have target Ganon, and he has health 1,000 health or 10,000 health. Fuck it, let's do 1,000. Okay, and then we could have a character named Link, right? And he's initialized with the address of Ganon. So I could then say, could I say Link? No, I can't do that. All right, well, if I had the address of Link, oh, I could do it like that. I can't do address Link, boom, boom. It has to be, so I could either say, hey, character pointer named Link P, and it's the address of Link. And what we could do is we could say Link P to get his target, to get his target, to get the health of the target. Or we could say the address of Link to get the character target, to get the health. Bunch of different ways to do stuff. Uh-oh, oh no, close that. Oh, yuck. Chaining is disgusting like that. Because we have to say, what in the fucking world? Oh, because we have to dereference an object to get its member, but the member is a pointer, so we then have to dereference that whole final thing. Just like we have to put the pointer in parentheses to dereference it, we have to put the remaining guy in parentheses to dereference him. And then we can get the member. Oh my! Okay. That's it. For a second. So we could do when using more than one. Alright. More self-test soon.